So we've been looking at esters and amides. I showed you briefly how to synthesize or make those, but we're going to now look at hydrolysis. And like most of the words that we learn, the word has some hints of what's happening. So hydro, I'm thinking water, and lysis, I'm thinking break. So we are going to, in these problems, find our functional groups. Here's my ester, or here's my amide, and I'm going to add water to them, and I'm going to break them. We're going to do this with the help of a catalyst. If you remember, acid sometimes helps with our water reactions, and so I have acid again. You might instead see that written as something like H2SO4. That would be the same as H+. So in terms of using water to break these, we want to think about, okay, I have water, I have that catalyst, and just a place that this often happens. For example, we're going to see a lot of these hydrolysis reactions in digestion because we want to digest and break our food molecules down to become smaller. Generically, here's what's going to happen. You're going to have two substances, I'm going to label them generically A and B, connected together. And when I add the water with some help from that acid, I'm going to lyse them or break them apart into compound A and compound B. So that's kind of generically what we're going to see on these reactions here. So let's start with the ester over here, okay? So it's ester. When I see that it's water, I want to label it as a hydrolysis reaction, and I'm going to chop it right down the middle, all right? So I want to box that functional group, and then I'm going to take that water, and the water is going to help lyse it so that I'll have back to my acid and my alcohol again. Basically, I'm taking this and just chopping it right down the middle to work backwards here. Now, what am I going to add? On the left side where there's the carbonyl here, so whichever side the carbonyl is on, you're going to add the OH because we break a bond, we got to add something new. And then on this side where you have just the O, we're going to add an H to it. So it's a lot like the same patterns we saw before, like when we did some addition reactions in chapter 11. If you break a bond, you have to add something to replace it, and that's what's happening here. So now we're going to copy and paste carefully. So H, C, H, carbonyl, and then here is that new, grab a different color, that new OH gets added on right here. Notice the O is connected to the carbon. And then on this other side, I'm going to copy carefully. So I have a CH3 at this end, a CH2, I have an O, and then I added the H on. And the red atoms there are from my water, right? So what I end up with when I lyse an ester or break an ester, I have an acid and an alcohol. And if you look up here, here's an ester, and it was formed from an alcohol and an acid. So I just did exactly the reverse. So I'm going to leave you some space here to practice, and you will do exactly the same thing. Find that ester group and lyse it, okay? Over here on the amide, it's going to be very, very similar. So again, I find the functional group. I figure out I have water and an acid, so this must be a hydrolysis reaction. Same thing happens. The water, I'm going to have the OH attached to the carbonyl side, and I'm going to add a hydrogen to the NH side. And then I'm going to copy and paste over to this side. So CH3, CH2, carbonyl, and then I have my new OH that gets added on. So where the bond was broken, I need to replace it with something. If you lose something, you have to replace it. And then there's a few ways you might see this written or formatted. So I might say NH2, CH3, I might see H2N, CH3, or I could even just draw it all out and show those H's, CH3, and one of these would be the new H that was added on. So any one of these three ways of showing your amine works. If you look, when I broke the amide, or amide, either way you pronounce it is okay, then what I get is I get an acid and an amine. And you can see that's exactly the reverse of what happened here. If I add water to this, I get an amine and an acid. So hydrolysis is the exact opposite. Lysine is the opposite of synthesizing or making. So you've got a chance to practice that again down here. All right, and then I just want to draw your attention to kind of looking ahead, what we're going to see coming up. So this is going to be in chapter 15. This is going to be in chapter 16. So what I'm looking at here is something I mentioned earlier, which is a triglyceride. And you're going to start to see a bunch of our functional groups come together here. You can see the cis alkenes here, but for this chapter, what we're interested in is that my triglyceride actually has 3 esters in it. And so if I eat some fat and I want to break it down, what my body is going to use is it's going to use water. And instead of having acid enzyme, you might have some acid catalyst. You might have some acid there, but you'll also use enzymes called lipases. Lipases break down lipids, and this is a lipid. So we will, in chapter 15, do these same reactions where we break an ester, but we'll break them on huge molecules. Similarly, in chapter 16, you will be able to look at something like this, which is a dipeptide or a segment of a protein, and find an amide in it. So this is what we're looking at here is called a dipeptide. So I can take that dipeptide and I can lyse it or digest your protein essentially. Again, you're going to add water and probably have some kind of acid. That's one of the things our stomach acid is good for. And then you'll take an enzyme from a family of enzymes called proteases, and those are good for breaking our proteins down. So that's where we're going to use this. In the meantime, you want to do lots of reaction practice. In this chapter, we saw these hydrolysis reactions. We saw some neutralization reactions, and we saw the reactions of just our acid and base with water. So you want to be able to practice all of those reactions.